Welcome to this Quantum Security and Defense presentation. Applications of quantum computing in finance, game changer, or is it just hype? And thank you for being a valued member of our community.
Gerhaard is Professor of Finance and Data Science at the Faculty of Business at the Baden-Württemberg Cooperative State University in Stuttgart. He has been working on the application of data analytics and machine learning in finance for many years. These methods also include quantum computing and the quantum machine learning that builds on it. He's published several MOOCs on OpenHPI on the topic of quantum algorithms and is the author of several recent publications on applications of quantum computing.
Thanks a lot, Anna, for the kind introduction and for inviting me to give a talk about this subject, the subject which I deal most of the time, application of quantum computing in finance and game changer or just hype. And I think the question is very important, and we will see in the talk or at the end of the talk that the answer is not so clear. I mean, if you look in the internet and LinkedIn and some publications, most people are very bullish about quantum computing in finance. Say, oh, it will be a game changer, definitely. But for me as a researcher, I think the picture is not so clear. And I will give you the arguments why it is quite difficult to give a really clear answer on this question. I want to start with an introduction, of course, and a motivation for this subject, and then I will go a little bit into detail into the main fields of applications of quantum computing in finance, where most people think this could be fields where quantum algorithms could be applied. It's basically optimization, special optimization tasks. It's about machine learning, quantum machine learning, where people think, oh, we can use quantum algorithms to, then we have to talk about to speed up, to get better models, to get better generalization of models. I will talk about then, of course, Monte Carlo simulation. There again, it's about speed. People think and hope quantum computing may speed up Monte Carlo simulations, so you can do your risk calculations in banks or in insurance companies within seconds, which may have a kind of business impact. And of course, quantum blockchain. Of course, this blockchain business, it's also related to security. We heard in the last talk about Shor's algorithm and the breaking of RSA, and this is of course also the topic here. The blockchain technology, which is on the table nowadays, it relies on the security, classical security systems, which may not be secure anymore when quantum computing is available, and so it's a topic highly relevant for finance. Quantum computing is finance. In finance, I would say it's not isolated. It's a part of a larger game. So I want to talk a little bit about the status of quantum computing in general, at least from my point of view. What's the status at the moment, how I judge the possibilities, but also, of course, the dangers or the problems which are on the table, and of course we'll then end with a summary of my talk. So a few words about me. As Anna introduced, I'm a faculty member at Duale Hochschule, Corporate State University in Stuttgart. You should know maybe I'm now in finance, in the economics department. Originally, I'm a physicist, so I did my PhD in the last century in theoretical nuclear physics, elementary particle physics, so just basic physics research. Then I left the whole field. I went to industry. I spent almost 20 years in industry at different banks, Deutsche Bank, DZ Bank, Deutsche Bundesbank for a long time, before I came back to university. So I learned here in the audience, many people are from business, from industry. In my view or in my life, I always experienced both sides, academia, but also industry and applications. And for me, it's very important to connect these worlds. So My role in research is also to connect, basic research with industry, with application, and for me, it's very important to get, to get in touch, not to lose the connections, not to do research. I mean, basic research which is disconnected from any applications. I want to do application-focused research, and this is possible at our university because we are very, very application-focused. My research is about application of quantum computing in finance. I'm doing this now for 5, 6, 7 years. I started 2018 when quantum computing was coming up, when IBM made it possible to get access to their quantum computers. In these days I became a Qiskit advocate, one of the first batch of IBM. So I'm now observing this field for a couple of years, and I'm in and now want to share my experience and my view in this field. As I said, the university I'm working is not famous for basic research. Most colleagues do no research at all. We are very application focused. We are teaching focused. Actually, it's one of the biggest universities in Germany. We have more than 30,000 students, 10,000 lecturers, and it's very important that people working at our university, all the teaching staff, they must have worked in industry. So there's no professor coming just from academia, which spend all the time at universities. He or she will not get hired. People must spend at least 5 years outside of university, so they bring back or bring in their industry experience, their business experience, because our students, they are also, they are hired by companies. So our students, they come to us, they learn, they spend 3 months at university and then 3 months in their companies. You see here our partners, and you see here, of course, some German names, but also some big players. They send their students to us for 3 years for bachelors, also for the master students, and we work closely with the students. It has the advantage, at least from my side of view, that the students, they bring the problems to our university. They say, okay, when we in our firm, in our company, we see the problems, and they discuss the problems with us. So we are very, very tied to the companies, to the problems. We know what's going on, and there basically we got also the push to spend or to do something with quantum computing, because firms like IBM or here Mercedes-Benz, they said, okay, there is quantum computing on the table. We want that our students they learn a little bit in their studies, in their bachelor and master studies. Quantum education and education research is also a topic which is on my table. In my table, especially education research for quantum education, because we see a big need for people in industry knowing a little bit, or knowing quantum topic. In Germany, at least, there is I would say, a big problem that quantum computing is still the business of physicists. Also, I am a physicist. I was a physicist. I consider myself not anymore as a physicist. And I think, or made the experience with you, if you start telling people about quantum computing from a too physics-oriented point of view, it's very hard, because physics is, of course, it's difficult, it's hard, and people, there should be other possibilities. So we developed other measures or other ways to teach quantum computing for non-physicists, for IT people, for business people. We produced some open MOOCs, which are on the internet, about quantum computing, which can be viewed um, without any cost. And we also looked at the experience. We published the results and the surveys of this courses to learn and to improve the methods to teach to teach quantum computing. So teaching quantum computing is a big issue. I think if this methods will come more to industry, there is a need that people in firms, in the companies, they know maybe not all the details, but they know that they should know at least the basic stuff about it. They should judge it. They should have an impression about it. They should talk about this subject. But my main focus today is quantum computing in finance. And when I started doing this, I said 6 or 7 years ago, my research questions were pretty elementary. The first questions I had: how does it work? I was curious. I'm always curious about new technologies, new methods. So I just wanted to know, how does it work? How can I do it? What do I have to do? What are the programming languages? What is the concept? What is this? How does it work? So this was the first my first keep in order come touch point with quantum computing and finance, and I learned I learned it is possible. It's not so hard. You can do quantum computing. It's possible. And then of course the second question which come into my mind: is there any value in applying quantum to finance? And this question is harder. It's because this question have different dimensions. When you read nowadays in the internet and in publications, when people talk about quantum advantage and quantum opportunities, they most of the time they compare algorithms. They say, okay, this algorithm is faster, then we have that's an advantage in business. But I think the question is not so easy. It's much more complicated, because in the first point you should think about, is there really the need from a business point of view to do something faster or get a more accurate result? Is there really a need to do it? And then do you have a quantum method to do it? So this value in applying quantum to finance is much harder, and we did some work about it, did some analysis about it. The beginning of the year, we published an article about it, a review article from portfolio optimization to quantum blockchain and security. So we published a systematic review about the work of quantum computing in finance, and we had in our heads exactly these questions: what is the value in applying quantum to finance? And connected to this question is an even broader question, an even more general question: what are the broader business and economic implications? And I would say this question, this is totally open up to now. If you look into the literature, I would say the classic economic literature, the classic economic people, nowadays they start to analyze and to learn about the implications of AI. But quantum computing is so far away, so they didn't even start to think about what are the broader implications about business in total, about markets, whole economic implications. And this is I would say this is a research question for the future, for the next year, and it's very, very interesting, of course, to tackle these questions, not only to do its algorithm faster, not faster, more accurate, but also view this broader economic or to look at these broader economic questions.
Thank you for watching this presentation. You can join the QSEC Deaf community to watch the full version of this and over 80 other lectures on quantum technologies, attend events, receive free training, and more. QSEC Deaf is a users community with over 700 members working to forward quantum secure communications. The community is represented by Quantum Security and Defense that provides supply chain orchestration and consulting services on behalf of our members. Find out more. Google quantumsecuritydefense.com.